So this is kind of yet another talk about asynchronous, streamy, functional, reactive stuff in JavaScript. But before we talk about JavaScript, I want to talk about this idea of FRP in general. Just so I get a sense, who's heard of reactive programming before the conference? Okay, and who'd heard of FRP before the conference? Okay, good. So I've talked about this actually randomly to a few people over the conference. FRP is a really good example of labels in computing being kind of confusing and overloaded. So if you ask some people what reactive programming means, it's all about kind of scalable back-end systems and immutable flows of distributed systems. For other people, when they say reactive, they get that kind of conflated or confused with things like React.js and kind of unidirectional data flow. There's some similarities, but there's also some differences there. FRP is another kind of thing that gets mixed up with this reactive meme that's quite trendy at the moment. Has some similar ideas to some of those other things I just mentioned, but it's also its own thing. And I think it's kind of an example of this famous quote, two hard things in computer science, caching, validation, and naming things, right? I actually prefer this version of the quote. So FRP. To make this even more confusing, the person who originally coined the term has kind of explicitly said that the way that most of us use it today is actually wrong, and that's not FRP. Now, he gets to say that because he came up with the term. So I want to respect that, and I think actually a better name and one that he agrees with is this term compositional event systems. The problem is we all now call it FRP. That ship has probably sailed. There's this term called semantic diffusion. It's too late. We're just going to call it FRP. So while I would like to keep calling it compositional event systems, I can't get my head to do that, so I'm going to refer to it as FRP during this talk. So what is FRP? It's a big topic, and it's quite kind of academic. But the way I think about it is kind of fundamentally, it's a different way of thinking about computation in our programs. It sounds like really big and confusing or scary, but hopefully, my goal in this talk is to show you that it's actually something we can wrap our heads around and use in our day job, or at least expand our minds and change the way we think about normal programming. So one of the most interesting differences in my mind when we talk about FRP is it changes how we model state and changes to state in our programs. So FRP introduces a quite different notion of how we represent values in our program, so the state of things in our program, how we model the relationships between different values in our program, and most importantly, how we model changes to those values over time as our program executes. So that's what I'm going to be trying to get across today is some of those differences between FRP and traditional imperative programming. So the big difference with FRP versus imperative programming. In imperative programming, we use these things called variables. And a variable represents a snapshot of a value at a specific state in time, a specific point in time. So I might ask, in the context of an HTML page, what's the current position of a slider? I'll call some function, and I'll get back a variable that represents the current position of that slider. If that slider then moves, that variable doesn't change. That variable only represented the state at a point in time. The difference, or the different idea that FRP brings is this idea of what I'm going to call streams. I think maybe Chris or other people might disagree with my terminology, but again, I'm going to stick with it. The difference with FRP is rather than representing values as variables, we represent them with streams, which represent not just the current state of something, but all future states of that thing. So rather than getting a variable that represents the current state of a slider, I can ask for a stream which represents the current state of that slider and all future states of that slider. And this small change can really fundamentally change how we think about building programs. And I'm going to talk about how we use these ideas in real life. I'm going to use the context of UI development. These are very general ideas, a very general purpose paradigm. But to get the point across, I'm going to be using examples, primarily examples with UI programming. And in the context of UI, FRP and this idea of streams boils down to three key ideas. UI elements produce streams of values. So for example, a slider and the current position of the slider can be represented as a stream. We use functions to combine and transform those streams into new streams. And those streams can be assigned to UI attributes to affect UI output. Now, if you take a step back, these three ideas kind of summarize all of the work that we do when we're programming user interfaces. We take some input from user interactions. We react to it by doing some form of calculation or business logic. And finally, we put that business logic back, or we affect output into the UI because it would be a very boring interactive program if nothing ever changed in the UI. So these are three general ideas for how we do UI programming. They're just represented in a kind of an interesting way in the context of FRP and streams. So my goal is to show you how this works with some real code. Maybe expand your minds a little bit. This might not be something that you kind of leave the conference and start using in your day job next week, but I hope at the very least it will motivate you to play with it a little bit more in your own time and maybe expand your brain and expand the way you think about the possibilities of representing things in programs. I'm going to be using a library called Bacon. How many people went to the other Bacon talk? Okay, good. Good. So I'm using Bacon. There's a few other libraries that are available. RxJS is a very good, powerful, popular one. Highland is another interesting one that's maybe FRP, maybe not. And a bit about me. My name is Pete Hodgson. I work for a consulting company called ThoughtWorks. As you can tell from my accent, I'm based in San Francisco, originally from the UK. And ThoughtWorks, we're a custom software consulting company. We help our clients build better software and get better at the process of building software. And we get to come up with our own job titles, which is nice. So let's get started with some examples. This is the scary bit where the screen doesn't update for a while. A long time. A little too long? Oh, no, don't do that. Okay, good. So, let me get rid of some of this code. Oh, this is not. Apologies. Scary. Okay. Hopefully this will work. Is that readable? Yeah? Okay. So we'll start with a really simple example. So we have a slider here and a div or some kind of place where we want to output some text. And my goal is to kind of wire these two up so that whenever I change the current position of the slider, it updates the value here. And I'm going to use a functional reactive approach to solving that problem. So here's some cheater code that I started with. And what we'll start off doing is asking for an event stream for this slider. So this slider is just standard jQuery way of grabbing that slider. And I'm going to use, because I'm using Bacon, Bacon has added to jQuery It has a plugin that adds one method to jQuery. This is the only jQuery specific thing that Bacon does. And this allows us to ask jQuery for every input event but represented as a stream. So now that I have that value as a stream, I can log it out to the console. And now when I whenever I move the slider here, you can see that there's a kind of a jQuery event is being logged out to the console. So that's kind of good. We're off to a start, but really I don't care about these events. Really what I care about is the values represented by that event. And I can kind of use this little handy-dandy function, which I already added up at the top of the screen here, to do an initial mapping. So I don't want the raw events. I want to kind of pass them through that little one-line function up at the top of the screen so that I can get more useful values. And now you'll see when I move the slider, what I'm getting logged out to the console is a kind of a stream of the stream representing the current value of that slider. So that's helpful logging it out to the console, but we can kind of do one better, and we can kind of visualize these things like so and give it a nice label. And so now whenever I have kind of a visual representation of this stream. Whenever I move the slider, you can see kind of a new event is occurring or a new value is popping up into that stream. And then finally, now that I've got that stream, I can do, so the first part is kind of those three big ideas was grabbing, representing kind of user interaction as a stream. So I've got that. And now I'm going to do that third thing of kind of using a stream to affect user output, or affect user input output, I guess. So I'll say values, assign, and I've got this handy-dandy jQuery object here, and I'm going to assign it to text. And now you can see I've got like really basic data binding going on. So every time a new value appears on that stream, it flows through that stream into that text label. And what's going on under the covers here is not UI specific, even though it looks like it's UI specific. So this values.assign is actually a general purpose way for me to kind of terminate a stream and put it back into the non-FRP world. So actually what's happening here is Bacon sees me say this, and it interprets this as whenever a new value appears on the stream, call this object with this method name and put in whatever is the value on the current value on the stream into that application of the function. And so in the context of jQuery, what that's doing is calling text, which is updating the text of that piece of UI. So it looks like this is something that's UI specific, but actually it's a general purpose way of terminating a stream and putting it back into the non-kind of functional world. Questions about this so far? Yeah.
Is this so far? So if I were implementing this without functional reactive programming, you have an event listener.
Yeah.
Output a new thing when the event comes. Change the UI state of the event is triggered. How is this different?
So as it is today, that's almost exactly what's happening. So under the covers, it's implemented in something very, very similar to that. There's an event listener being attached to this jQuery thing, and it's eventually calling some method. So it's not. The example as it stands today is conceptually pretty similar in the same way that callbacks are conceptual, or promises are conceptually just callbacks with some stuff around them. So we'll get to why, hopefully as we go along, I'll show why adding this kind of abstraction on top of that kind of mechanism gives you some powerful benefits. But yeah, under the covers, it's very similar, at least for now. Other questions? Yeah?
Where did the values.visualize come from?
Values.visualize is, that's a good question. That's actually something I kind of sneakily added to Bacon for this presentation.
Is it like a mix-in API, or do you like patch it in?
It kind of has a mix-in API. It was a long time ago, or a while ago that I added it, so I can't remember. I feel like I was 80% legit and 20% kind of horrifically monkey patching. about that ratio. And it's something that I kind of keep on meaning to kind of make like package up and put into a library. I haven't quite got there yet. Yeah. Okay. Okay, I'm going to keep going. So that was the kind of just really basic data binding. Now let's talk about that middle piece of transforming these values. So let's say rather than having a slider that goes from 0 to 1, I want to represent that as a percentage. So I want it to go from 0% to 100%. So the first thing I'm going to do is, so you'll notice that maybe you noticed that these values flowing through this stream here are actually strings, so they've got quotes around them. So the first thing I need to do is parse this value into a float. So I'll say parsed is that value mapped through a function, which is just going to parse it into a float. And parse float is something that comes with JavaScript. And we'll visualize that just so we can see what's happening. Oops. And so now you can see I've got a new stream unrelated to the original, or it's not tied to the original stream. It comes from the original stream, but it's not, they're kind of divorced at the point I've created them, and now I have a stream of floating point numbers that I can work with. So next thing I'll do is turn that into a percentage. So again, we're going to map it through another function. And I'll do like math.round x times 100, and we'll visualize that. And now you can see I've got kind of these rounded percentage values. And the last thing we need to do is format that into a nice string so that we can output it. So we'll say %.map through a function, and we'll do some horrific JavaScripty things and assign that to the label as we did before. And ta-da, we have kind of a very basic data transformation going on. So this is kind of a really simple way to kind of represent what I meant by that second part of the kind of the triad of things we do in UI programming, of kind of transforming input into new values in a kind of an immutable way, and then pipelining that into some output. And here's the kind of the code that represents it. As you can kind of imagine that in a real-world program, I would do kind of something similar to the example that Venkat had in his keynote, where I just kind of pipeline all of these together and chain them. So I'd say, you know, as event stream, dot map, blah, 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 dot map, blah, 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 dot assign, right? So for the purposes of kind of making it easy to understand, I've assigned individual variables, but in real life you just chain these together, and it's one of the nice things about having immutability is you can just do that. Questions about this so far? Make sense? Yeah. Map is very, very different in this context than array. So the semantics of it are very similar. I'm taking a sequence and I'm applying some transformation to it to get some new sequence. The difference is that so I'm going to steal something from Chris's talk. In arrays are kind of spread across a space dimension, but a single point in time. Streams are kind of like if you rotate that entire thing into the time dimension. So it's a single value that's going through at different points in time. But you're still essentially mapping that into a new stream. So yes, yep. It's all the same idea, pipes and filters essentially. Yeah. Okay, I'll move on. So that was our first example. Now I want to talk about a little bit more complicated example now that should show some other features. So here I've got two different sliders. And what I want to do is, as before, kind of assign some values to some text output here, but I also want to do some basic math. So I want to say, if this slider is, the first slide is at 2 and the second slide is at 8. I want to sum them up and have 10 come out at the bottom here. So we'll start off as before by saying values A is that slider A, and we want to do it as an event stream, and we want the inputs, and we want to cheat and put it through that little function. And then we want to do the same thing with B. So we'll get a second stream, and then we'll visualize those guys so we can see what's going on. And we've now got kind of, basically we're back to where we started, where we've got our streams. Let's assign them. So we'll say values A dot assign to label A, the text attribute. Same thing with B. And so we've got the first part going here where we've got our basic kind of data binding. Now the next thing we want to do is combine these two streams together. So we need a stream that represents the kind of the combination of these two values. And so the way we do that in Bacon is we say combine with, or one of the ways we can do it is combine with some kind of summer function, and we'll say var summed, and we'll say values A, values B. And this is going to combine the values that come from A and the values that come from B through some function that we have yet to define. So let's define that sum function. It's a function. It's the most boring function you can imagine that sums up two values. And let's visualize those. Hopefully, if I did that right. Oh, look. Who wants to tell me what's going on here? Yay, strings. Thanks, JavaScript. That's exactly what I wanted to do. 2 plus 7, 27. So I forgot to transform these streams into floats. So let's do that. And let's just do it up here, kind of in a more kind of or a more idiomatic style. So we'll say map through a parse function, and then we'll do the same thing for these values, and I think that will work. Yeah, JavaScript can now do basic math. So we're most of the way there. Let's pause for a second, though. I've been doing a lot of copy-paste, and although this is a more kind of declarative way of working with JavaScript, this is still JavaScript, and I can still use good programming practices in this context just like I would in any other JavaScript program. So let's kind of dry this up a little bit and make a little helper function. So we'll say value stream from slider is a function which takes a slider and does that stuff. So this is just the general form of what we were doing here. So now we can kind of say value stream from slider, and same thing for B. Dry it up a little bit. If I did that right, my unit tests will pass. I'm a manual unit tester. I'm actually not. I'm a big fan of unit testing, but you guys don't want to watch me write tests. So what I wanted to kind of, the reason I did that is I wanted to kind of capture this idea that just because we're working in a higher level, kind of more abstract way, we're still able to use, because we're still in JavaScript, we're still able to use all of the tools that JavaScript gives us to kind of compose things, abstract things, all the good stuff of a regular language. That's one of the things I like about things like FRP. I think they're a good kind of compromise between building a whole new language to describe this higher level concept versus embedding a more powerful concept in an existing language. So I think we're almost there. The last thing that we need to do is just assign this value to the summed label. And I think we have achieved our mission, I hope. Yeah, so you can see now I have two sliders that are combining together to form another slider. And one of the things that I want to highlight here is how little noise there is in this program. So I've added kind of a fair bit of noise by doing all of this visualize, and I could have summed these together. But if you look at this program, I think this really represents what Venkat was talking about in his keynote around inherent complexity versus accidental complexity. This program captures just the inherent complexity of the program without any of the noise. So an example of that is the fact that when these two sliders move, I need to sum those values up together. Now, if I did this imperatively, what I would do is I'd have an event handler. So this goes back to the question of, like, isn't this just like event handlers? I can imagine if I was doing this imperatively, when I'd have an event handler for both, and then when it changed, I'd write down like the new state of that value, and then I'd look over there and get the state for the other slider, and then I'd sum them together. And then if it was the other slider, then I'd have to kind of remember this value and go and get the other value. And I'd have to do a lot of kind of tedious housekeeping that's totally unrelated to the problem I'm trying to solve. It's just the kind of craft that computers make us do because we're dealing with state. Now, because FRP abstracts over the concept of state, I don't have to do any of that work in my program, and it means that my program is just focused on the fundamental work at hand, and all of that other noise has been removed. So I think this is one of the real wins of this kind of more abstract declarative style, is it's boiled down to just the fundamental complexity of my program, kind of represented in a more kind of canonical way. And there's none of the noise. It's a lot easier to understand. Questions about the implementation so far? Anything that didn't make sense? Yes? Mm-hmm. Yes. Yes, I will get to that in just a second. Yeah, yeah.
I assume that there are ways to like repeat the last value every time you move one of the sliders, you get a sum. Is that correct?
That's what's happening. Every time I move one of them, I'm getting a sum.
It seems like if you run out of values on one of the streams, then it waits until the value comes to zero on the next stream.
Yes. There's always it will always take the present value from both streams. So you can see here there's kind of the 6 and the 4.
I thought you were dragging when you were clicking it.
No. So every time one of those changes, so it's waiting for there to be a value in both the streams, and then it's so all of that logic is kind of built in. It's implied. Other questions? And again, this is in the context of UI programming, but you can imagine just as easily these two sliders could be two network requests that I sent off, that I need both network requests to come back before I move on to return some response to the client. The exact same programming patterns can be used. In fact, the exact same functions are used, just in a different context. And again, that's why this is different from just using event listeners or just using node streams or something like that. It's the exact same, not just the exact same patterns, but the exact same API and method calls used in all of these different contexts. I don't have to relearn how do you take the first 5 values from something in node streams versus with an event listener, for example. It's a shared kind of, it's a shared concept that is general purpose. So you asked why do we have to wait for both of these streams to have value. So it kind of makes sense when you think about it that at the point, now why did that, oh, because I deleted all the visualization, haha, handy dandy. So at the point that I'm moving one of these sliders, it kind of makes sense that there isn't a summed stream because there is no current value for stream A, because I've never moved that first slider. So as far as this stream is concerned, it hasn't been initialized. And so our summing function, or our combined stream, is waiting for some input to arrive. Now, in this context, there actually is a way that we can kind of load up some initial input. So let's make that happen. So up here where we're doing our sliders, and I've forgotten what the syntax for it is. I might have to. I'm actually having a total brain fart and forgetting whether this is how you do this. No. No, could you start with, I guess, huh? This is live coding to the extreme, huh? Is this going to work? Yay, thank you. So now, so what I did, with some help from the audience, was I said, start this stream with an initial value. So in the context of this program, we actually do have an initial value for the stream. It's the current value of the slider kind of when the program boots. So we can kind of prime the pump, as it were, and tell each stream what to start with. And what that means is now when we move these, they're already primed. It's actually not it's not the same. And I'm totally spacing on what the method name is to turn it into a property. What was your question?
So why does the sum also start with a value if both its input streams are starting?
Yeah, it should be. It should be in the example that I normally use. Does that. And I can't remember at all to property. Thank you, there we go. So I'm converting it to a property, and I believe if I do that, okay, there we go. So now that my brain has re-engaged, what's happening here is I'm converting this thing into a property, and the idea of a property is it's something that always has a value. So you can think of some things as being only having a value at a moment in time. So the position of the mouse cursor, for example, is only kind of valid at a specific point in time. It's kind of transient. In contrast, something like the position of that slider is something that's kind of permanent. You can a slider always has a position, always has a current value. So what I did when I converted this into a property is I converted it into something which always has a value, including an initial value, which I provided by just grabbing that val from the jQuery object. And so now, when we start this thing, you can see that it kind of primes the pump, and values flow from those initial sliders, get combined together, and get assigned to the output at the end. Although it's not assigned to the output at the end. I think I broke something. I think I just forgot to assign it. Yeah, I undid some stuff I shouldn't have done.
So like a stream doesn't have an option to get the last value. You have to subscribe to it, whereas a property kind of sort of does.
Yeah, so that sums up, that question kind of sums up a question I get a lot, which is, I think the reason we ask questions of like, can I see the current value of a stream, or can I see the last 5 values of the stream? And almost always, what I've found is when we find ourselves asking those kind of questions in the context of FRP, it's because we're thinking in an imperative way. We're thinking that we want to perform some logic at the point that we're processing something by kind of reaching out and asking questions of things. And the fundamental model with FRP is streams are flowing through and we react to those streams changing. So for your question of can we get the most recent value, I think you technically can, but you almost never need to, because you don't want to ask for the current value. You want to react to that, to the always current value flowing through these streams. Now there's a broader question of can I get the last 5 values, and you can do some things where you can kind of take those and chunk them up into arrays and then pass a stream of arrays through. But you're always doing the same idea of reacting to values flowing through a stream.
So what are the semantics of these streams? I guess it's specific to Bacon, JS, but is delivery guaranteed? Drop?
I actually don't know. So what are the semantics? Are they like on the same turn of the event loop or a subsequent turn? Do they drop, all that kind of stuff? I actually don't know in the context of Bacon. I mean, it's one of the things that kind of Chris was talking about a little bit in his talk is kind of push versus pull and back pressure and all that kind of stuff. Bacon definitely doesn't have the some of the functionality that node streams have, for example, because there's only a one-way information flow. I can't tell a stream like, hey, you're overwhelming me. On the flip side, the programming model is way, way simpler. Yeah. Yes?
So coming back to another question, I'm not sure I understood. If you were to say instead of adding two numbers, you were doing like a moving average, just on one number, you had a stream coming in and
Yep.
like 1, 2, 3, and you want to show the average of the last 2
Yep.
or 3, would you have to then store that state in your transformation function, or you're trying to abstract away states?
Yeah.
Right? I'm
Yeah.
not sure where it would go.
So the answer is, so there's these primitives that are available to you beyond map. So there's something called scan and there's something called reduce. And what scan does is it's like map where it takes a value and transforms it, but you also have some context or some state that you can kind of keep going round each time you get an event. So you can think of, for example, if you wanted to do a sum, you'd take the running total and then that gets put back in the stream so that the next time something comes in, you can take that running total and add something to it. And you take that general principle and you can use it to do any of those things of a running average or an array of 5 things. So it's the fundamental reason why you have something like scan or reduce is the state problem, right? You need to keep some kind of state as you go along, but so where does it go? Because in a well-implemented FRP system, you don't have variables because you don't need them. So you have to deal with that some other way. Other questions about this implementation so far? Yeah. Yeah, so there's loads of ways that you can create a stream. You can create a stream from like just an array, for example, if you want to kind of preload it with a constant. You can take a promise and convert it into a stream. You can take a set of callbacks and turn those into a stream. Bacon has a thing called a binder, which lets you take, which kind of lets you arbitrarily make custom streams based on callback functions. And it comes kind of loaded with some convenience things for jQuery, for node callbacks, for promises. So actually, at the beginning of the talk, while I was waiting for the talk to start, I had this example that was using some pub/sub, using a library called pubnub. And to implement that, I just wrote a custom binder, and it was about, I don't know, 5 lines, maybe 10 lines of code. So it's quite straightforward to kind of make your own custom streams if you're not using one of these systems. There was another, yeah.
So in RX, you can subscribe and then you're done at some point.
Mm-hmm.
Is that a thing you can do here?
Yeah, I think so. So I mean, kind of to generalize your question, is this how similar is this to RX and how is it different? I think RX has some more powerful concepts. It has kind of hot and cold things. Bacon is a little bit more simplistic, but all of the core functionality is there. So a stream can terminate, and you can respond to that termination, all that kind of stuff. Yeah. Okay, I'm gonna kind of go back to some theory. If I can make my computer work. So I started off with this concept of the difference between variables in an imperative program versus streams that represent not the current value but all values. And what I'm hoping I kind of gave you a taste of is what that means in a real program. You're still doing some of the same things, but you're working at a higher level of abstraction because you no longer have to kind of store state and kind of decide what to do based on different state, you can just declare how you want those values to relate to each other over time. I was talking about it in the context of UI because I think it's easy for us to understand. Let me kind of wind this all the way back to like a really, really basic example. Here's a variable. It has the current value 12. On this line, I am saying that b is equal to a plus 10. And at the moment that my JavaScript engine evaluates this line of code, that is true. Now that is not true. b does not equal a plus 10 because a has changed. Most of us as programmers believe that this is okay and that this makes sense. If you show this to normal people, it doesn't make sense. This is the equivalent using something like FRP. A is equal to 12. B is equal to a plus 10. When I change a, b is equal to a plus 10. I'm stating a truth that will always be true, and I'm done. I never have to think about this again. So this is something which normal people think computers do for you. They can do it for you. If you've used Excel, you've seen this happen all the time, right? Excel is a great example of FRP. It's kind of a really well-known kind of way of saying like FRP is like Excel. When I change a value, when I relate two values in Excel and then I change a value over here, it just works. There's a reason why normal people can use Excel. There's no excuse for us doing this work. Like, why do I have to tell a computer, oh, I changed A, so can you make sure B is up to date? I already told the computer what I want the relationship to be between these two values. Why do I have to do any work? So this is the thing that I get most excited about with FRP is it makes me realize that there's a bunch of stuff we do that we shouldn't be doing. There's a bunch of code that we have to maintain that is totally unnecessary. We have Stockholm Syndrome and we think it's okay. It's not okay. So this was some really basic examples using UI. And I just touched on like the real basics of kind of map, and we talked about reduce and scan a little bit and combining streams. There's a bunch of other stuff that comes with Bacon, and these primitives are similar to primitives you've used in lots of different contexts, but they're shared. So if you know how to use this in Bacon, you can use it for UI programming, you can use it for an embedded system, you can use it for network programming on the server or the client, and you don't have to relearn how do I debounce something in this new place, right? Like once you've learned how to debounce something, you've learned it and you don't have to relearn it. So that's one of the really powerful things about Bacon. It's a shared kind of paradigm. And again, we're just getting started. I was just talking about UI programming. So I didn't talk about some of the really trippy stuff with FRP where you can model time directly. So you think about the idea of values that change over time. Time is the definition of a value that changes over time. With a stream, you can actually represent time directly in your program. And when you start thinking about things that way, you can start doing some really surreal things in a very easy way. Obviously, this is all about asynchronous programming. You can use this for anything where you're dealing with asynchronicity. So embedded systems is a great example. Anything where you're dealing with events that may happen over time. It's a great model. And it's obviously totally valid outside of the UI. So I've got a really quick example showing how you might use it outside of the UI context. I'm actually not using, sure, delete it. And in this context, I'm not using Bacon. I'm using another library called Highland, which is fairly similar, but it has a lot of the same FRP ideas, but it works with node streams, so it's more interesting on the back end. Oh, yes, I am. Thank you. OK, so this is a node server. And what it's doing is it's looking up artists on Spotify and finding related artists using their API. And so So I have a server. I do some ugly stuff to grab the artist name from the URL. I default to Taylor Swift. Why not? And then I write out some HTML in a highly secure way. And then I start doing some FRP. So I search for an artist using that name, and that actually, if we go and look at that implementation, it's making a request and then piping it through a parsing function, and then turning that into an FRP stream, doing some flat mapping to turn an array of results into a stream of individual results. I don't think I'm going to have time to explain flat map, but come and talk to me afterwards if you'd like to know more. And then I'm grabbing the ID. So that gives me a list of artists that match that name. I then take the first artist, because I'm only interested in the first result. And then I apply that. Essentially, I've got now a stream of one ID. And then I pass that ID in to make another stream that, again, kind of makes a request and turns that request response into a stream. And then I do some more FRP to map that into a list of names. I flat map that again, and I'm not going to explain what that means. I map it into some HTML, and then I pipe that into the result. So I rushed through that really quickly because I don't have time to talk about it in more detail. The end result is you can find out artists that are related to other artists. So this is interesting. But again, the thing I wanted to get across is, although this is a slightly more complex example, I actually think this is, again, like there's not that much accidental complexity here. It's a pretty close representation of the pretty direct mapping of the problem space into an implementation. And again, it's using the exact same paradigms that I've used in the UI on the server side. So I don't have to relearn how do I take the first value from a stream of values, for example. So that's one example of, another example of how you might want to use FRP.
What's the advantage there of using what Highland over just using regular streams
Regular streams
as transformation?
like node streams. It's just a nicer API, in my opinion. And again, it's an API that's consistent, or can be consistent between client and server. So, I mean, all of this fundamentally is just JavaScript, so it's just function calls. But I think if you implemented that with node streams, it would be a little bit messier. And you'd be pulling in a bunch of extra libraries. So one of the frustrations I have with using node streams, for example, is whenever I want to do anything other than just essentially write some output, I need to pull in another library. And I always end up having to Google for how do I combine two streams together. If I'm using a shared paradigm like Bacon or like Highland, it's baked into, all of that functionality is kind of just available for me without me having to dig into the low-level details of how streams work. I think it's a nicer abstraction over the concept, yeah. 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 Not that I know of. Some of the names are very standard, like map, scan, take, flatten, flat map. Some of those are very standard, but I mean, there's nothing like kind of the A+ promises spec or anything like that I'm aware of anyway. Okay, so that was me talking through that example. Thank you. One thing I will ask you to do is give me some feedback on this talk. I'd like to improve it over time. So please take 1 minute out of your day and give me some feedback. Hopefully, this has kind of got you a little bit excited about playing with this in your spare time, and maybe you'll use this in your day jobs. Thank you. And I really like talking about this stuff. Come find me on Twitter or email me. All the examples, I think, are on this website. And I'm going to go to Surly for beers after the conference. If you would like to join me, I will be in the lobby after the keynote. And I will take other questions now, because we've got another 10 minutes. Yes?
So I've been doing a fair amount of RX lately. Sometimes I feel like after I'm done figuring out what I want to do, it ends up seeming a little
Yeah.
I mean, do you think that there are? Do you think that this paradigm works for sort of everything, or do you think, or like, how do you decide when you're going to use a string-based symbol versus promise versus just sort of traditional?
Yeah. I mean, so to kind of paraphrase that a little bit, it's like, when should we always be using this paradigm for everything, or how do we decide when to use different paradigms? I don't have a really good answer for that. I think part of it is just familiarity. If you look back to like 3 years ago, people thought the idea of using promises was a controversial idea, right? Like, oh, promises are so complicated, I can just use a callback. And now they're kind of in the standard. I don't think there's going to be a functional reactive thing in the JavaScript standard anytime soon. I think there's an element of that where it's just familiarity. You are trading off. Sometimes it's more complex to represent a simple idea because you have to not use state. In exchange, you're always using the same kind of base operations. So maybe it's easier for people to understand when they come back to it in a few months' time. I don't think you should model everything this way. I think there's some kind of things that just don't fit with this paradigm. I think it's probably there's more things that do fit than we would guess today. I think there's more places that you could use it than we do today, for sure. Yeah. Other questions? Okay. Thank you.